let's take a few minutes and talk about what the statistics mean for the iReady pretest. This is looking at the data from 10:20 in the evening, actually. So we're getting pretty close to having every single kid pre-tested. So at the top we talk about regional usage, and we've got listed by region how many kids have been entered into iReady and how many kids have been pre-tested. Now, all the kids are still there from last year if you look at your own individual information by logging into iReady, but this represents only kids who are assigned to tutoring groups. So there may be some kids in there who are current students but aren't in a group. They will not show up on these data. So that's what we're looking at. Region, how many kids are entered, and how many kids have been pre-tested. Now, we have a state-by-state examination also. Arizona, kids in, kids pre-tested, and so forth. If you do the math yourself based on the previous numbers, they won't add up correctly. In this case, New Mexico includes Texas too, which is the Las Cruces area, because those kids are in New Mexico. And Texas does not include Texas 2 kids, only Texas 1 kids who are over in the El Paso area. But the totals work out the same, both for the number of kids entered and the number of kids who have been pre-tested. Okay, so this is pretty basic stuff. Now let's get a little bit more tricky here. So we have your average reading level to grade level gap per region, which means on average how far are kids behind in their reading ability from their actual grade level. So we've got our averages, but we also have the standard deviations for each region. The standard deviation is going to give us an indication of how closely the scores are clustered around that average. And you see, these are pretty large standard deviations, which means for the most part the kids are well distributed. They're very scattered. Matter of fact, the smallest one is this group of students down in New Mexico 6 with only a 0.5 standard deviation. But overall, the kids are not very tightly clustered around that average. They're just basically scattered all over the place. So let's take a look at what these standard deviations imply to us. Now, we have to assume a normal bell curve. If we don't have enough students, like in this New Mexico 6, it's not a huge group, so we may not have this bell curve. But let's see what it means anyway. So if we have an average of 1.2 grade level gap and a standard deviation, what that means is that approximately 68% of the kids are going to have between a 0.7 grade level gap and to a 1.7 grade level gap. So that's 68%. And if we look at 2 standard deviations from the mean or from the average, we're going to see that 95% of the kids have between a 0.2 grade level gap to a 2.2. So if we start with the mean in the middle, which is the 1.2 grade level gap, and we move 1 standard deviation in either direction, both negative and positive. So half a grade below to half a grade above the average. That's where we get that 0.7 to 1.7 grade level gap. Now, with 2 standard deviations, we're going to pick up 95% of the scores, approximately, if we have a bell curve, an actual bell curve. So 2 standard deviations below the average is 0.2 grades, and 2 above the average is 2.2. So about 95% of the kids have a gap between 0.2 grade levels and 2.2 grade levels, and that's how we interpret those standard deviations. But you see, that's a fairly large spread. But let's look at another one just to go over that again. So here we've got, let's take a look at New Mexico 4. Nope, let's move on down to New Mexico 10. So the average is 1.5, and we have a 0.8 standard deviation. So let's see what that means for these kids. There's our 0.5 average, 0.8 standard deviation. All right, let's plug these numbers into my calculator. So there's our average, and there's our standard deviation. And what that means is that 68% of the kids are going to have a grade level gap of 0.7 grades to 2.3 grades behind their school grade. They're reading below their school grade. However, when we look at 2 standard deviations, when we move farther away from the mean, we see that the gap is a minus 0.1 to a positive 3.1. Now, we're measuring gaps as a positive number. So a gap of 1 is going to be a 1 grade level gap. But a negative gap is going to indicate that students are above their grade level. It's not a gap, it's a negative gap. So instead of moving lower than their grade level, we're actually above grade level. And this kind of makes sense because if we look at the overall grade level gap distribution, what we see is that we have 37 kids on grade level, and we even have 4 kids who are above grade level. They're at least 0.1 grade levels above, reading above their school grade level. So we actually have 41 kids who are at or above their school grade level. And that's how we get that negative gap in some cases. But remember, we have to assume that we have a regular bell curve for these, and the smaller the numbers that we have, the less likely that is to be the case. So let's try another one with a negative gap. So if we have an average of 1.7, a standard deviation of 1.2, then 68% of the kids are between 0.5 and 0.29 grade levels behind. And when we look at 95% of the kids, 95% of the kids are in the range of 0.7 above their grade level to 4.1 behind their grade level. So we have to be very careful about how we interpret that. And that's why I added that standard deviation, so you can look not only at how tightly clustered the scores are, but what's the approximate range of all the kids' scores. All right, so this one's standard distribution by grade, just how many grades per kid, or how many kids are in each grade level. That's pretty obvious. Here's the average reading gap by region, and you see that huge 5.5 up there, but we know that that has a very large standard deviation also. So we have to take these data with a lot of care in how we talk about them. So it's easy to say, oh yes, on average 5.5 grade levels behind, but we've got a 3.1 standard deviation in that particular case. So if we look at that more carefully, we know that 68% of the kids have a gap of 2.4 to 8.6. And see, here's how it gets ridiculous. A minus 7.7, but 11.7 grade levels behind. Just see, that just doesn't even make sense. So we have to be very careful about how we talk about these, and that standard deviation is quite important in understanding what those numbers actually mean. All right, so let's take a look at the next graph. We have to report on 3rd, 8th, and high school kids, and we see that, for example, 4.32 8th grade kids are approximately 4.32 grade levels behind. High school kids are approximately 6.28 grade levels behind. But interestingly, if we take 8th grade and we subtract this 4.32, that puts those 8th grade kids right in the middle of the 3rd grade reading level. And if we subtract the 6.28 from high school, which is grades 9 to 12, that also puts us back in about the 3rd, 4th grade reading level on average for those kids. What that indicates is that pretty much reading instruction and reading growth stops around the 3rd or 4th grade kids on average for the kids whom we are tutoring. So there's a lot of ways to understand that, but one speculation is that kids after the 3rd grade are not getting those fundamental skills, the phonics, the phonemic awareness, and oral language development that they need to access the higher level skills, and their progress in reading just stops. Now, distribution of grade level gaps. So in this first column, for example, these are all the kids that are from 0.1 to 1 grade level behind. We've got 821 kids who are 1.1 to 2 grade levels behind, and so forth. Now, iReady doesn't measure parts of grades after 1 grade level gap. So they might be a 0.5 behind, but then a 1, then a 2, then a 3. So for all practical purposes, this gives an indication of how many grades behind they are. So 3 grades behind, 4 grades behind, 5 grades behind, and more than 5 grades behind. So this gives us just an idea of where our kids are in general, and as expected, the majority of our kids are only 0.1 to 1 grade level behind in the reading. That's 1,252 kids, and you can just read the rest of the numbers there. So that's a quick overview of how we interpret the pretest data. I'll keep updating it as time goes on.